Welcome back, students. Again, this is the VLSI series, UNIT2 combinational circuit logic we are learning. So in that we are studying about the dynamic circuit logics. So in that series, now we are going to discuss about the topic dual rail domino. So this is a slight variation of the traditional case of domino logic. So where we know the domino is an implementation of dynamic circuit. But in domino logic, the drawback that we have is it can implement only the non-inverting functions. Like it can easily implement AND function or functions. Like that kind of non-inverting functions are implemented in domino logics. So to implement in inverting functions like NAND, NOR, so those functions we need to have some other kind of network. So that is why we are going with this dual rail domino. And generally the non-monotonic functions can be implemented using domino logic by simply computing both polarities of each signal. So actually here the circuit that we are going to discuss is about dual rail domino, which has two wires. So one wire represents that one wire that goes high if the signal is true, and the other wire that goes high if the signal is false. So this is just an introduction. So then we'll see about this circuit. So the dual rail domino in simple can be treated as it is a dynamic Cvsl, because we already know about what is a static Cvsl, cascade voltage switch logic. So this is just a dynamic type of Cvsl, where this is going to accept both true function as well as the complementary inputs for computing the output. So this is exactly identical to the static type of Cvsl. So since this static type of Cvsl uses two cross-coupled PMOSes, here we are going to replace the two cross-coupled PMOSes instead of connecting them with a pre-charged clock. So that is the difference we are making with this type of dual rail domino. So instead of cross-coupled PMOS transistor, so here a pre-charged clock is connected with the PMOS, and therefore this dual rail domino can be viewed as a dynamic form of Cvsl. So it is called as Dcvs, dynamic cascade voltage switch logic. And while discussing about the feature of this circuit, so this dual rail domino circuit is the fastest way to implement any given function, and it is widely used nowadays for arithmetic calculations and in fastest microprocessors, also in many microprocessors. So we are using this logic, and since the dual rail domino produces both the true as well as complementary output, it requires more area, wiring and power. So this would be the drawback of this circuit. So while discussing about this dual rail domino in simple, you can remember, so this dual rail domino is actually a dynamic type of Cvsl. So in static type of Cvsl, we saw that the two PMOS transistors cross coupled, but here you could see in this diagram the two PMOSes are connected with the pre-charged clock. So that is the difference. And since this is a dynamic circuit, at the foot we have to connect one clocked NMOS, so it is connected, and then the functions are implemented with both true and complementary inputs. So one side you will get a true function, and other side you will get complementary function. So the functional block is represented as F and F bar. So in one side you are getting Y output and other side Y bar. That is a complementary output. So this is the basic structure of a dual rail domino. And then the basic structure is now implemented for an AND NAND circuit dynamically. So previously we discussed about a static form of AND NAND structure, that is Cvsl. So the same Cvsl is now little bit modified. Just the PMOS are connected to clock, pi signal pre-charged clock, and then a footed NMOS with the clock input is connected, and remaining connections are same. Since it is AND NAND logic, in one side of the ring you will be having true functions. A and B are inputs, and in other side the complementary inputs we have to provide. So the connections also complementary. Since here we have made the A and B in series, so here you have to make the AB parallel. And then while taking the output from this circuit Y and Y bar, we use a static inverter. So this reason we already know, because in dynamic circuits you cannot connect the output of this dynamic circuit directly to another dynamic circuit. So that we use a static inverters in between. So for that purpose, buffering purpose, we use a static inverter at the output side. Okay, so this is the general structure and then AND implementation of a dual rail domino circuit. So finally I am summarizing the circuit, dual rail domino circuit. So this is exactly like your static Cvsl, except that the PMOS are connected to clock here, where in static type the PMOSs are cross coupled, and here as it is dynamic circuit, you will have an footed NMOS transistor at the end. Okay, and this circuit, it produces both the true function as well as the complementary functions. So in one side you will get the true function as output, and the other side you will get a complementary output. So that is, in one side AND function it can implement, in other side the same circuit can implement NAND output. That is, simultaneously you can get both the outputs, AND and NAND output. Similarly for the other function, so this is AND NAND structure, we can also extend the logic for XOR and XNOR operation, where XOR is true function, XNOR is complementary function. So it can be extended like this in dual rail domino logic. So the advantages, this circuit is fastest, but the drawback is, so this circuit is highly affected by what is called the power, because since it uses more area and more wiring, and it consumes more power. Thank you.